Welcome to today's webinar on unlocking the true potential of cloud without the cost surprises. Before we get into the session, I would like to take a minute to set the context and the direction of today's session. Now, studies highlight managing cloud spend is among the top cloud-related challenges for organizations. Common pitfalls such as over-provisioning, inefficient resource utilization, and legacy operational practices have been gradually adding to uncontrolled cost buildup. And among the top ways businesses are revisiting their cloud strategy in the current economic climate is by diving deeper into their cloud billing to understand what are the current and future costs to drive efficiency and scalability while avoiding cost overruns. A cloud optimization and FinOps approach focusing on investing in the right areas and improving resource utilization can help achieve optimal cloud economics. And this structured approach includes a strategic framework such as the 3693 strategy of optimal cloud economics that emphasizes a phased approach to gaining cost visibility, optimizing resource utilization, establishing governance, and continuously improving. So, in today's session, we will explore some of the practical cost saving strategies, including right sizing instances, optimizing storage, and leveraging commitment based saving models to achieve significant cost savings. And we will further uncover best practices for achieving optimal cloud economics using the 3693 framework. And to unlock what this framework is and how organizations can go about their cloud cost optimization strategy, I would now like to invite Suneet Parekh, Service Lead Enterprise Modernization Platforms and Cloud Service Line at ThoughtWorks India. Welcome, Suneet.
Hi, Shupra.
So, Suneet, you can take it forward from here. But before you start, I would urge all of you who are watching this webinar to keep sending your questions in the Q&A section, which is at the bottom of your screen. So we will be taking up these questions towards the end of the webinar. So feel free as you are going through the presentation, whatever questions you have, just keep sending them in the Q&A section and that's it. So we want to keep it as interactive as possible. It would love to hear your questions. So Suneet, over to you.
Thank you, Shupra. And it was a pleasure on the platform to present the 3693 strategy, which has helped ThoughtWorks as well as many organizations that we have worked with to optimize their cloud cost and have the optimal cloud economics. And I'm going to help you unlock the true potential of cloud without the cost surprises. That's the idea here. And I'm looking forward to answer your puzzles questions that you have uh, in related to cloud cost. So quickly moving on, I think I'll be covering the 3693 strategy overall for the cloud cost optimization. That's the objective of the session. So the first part is the rise of the cloud usage and cloud infrastructure is inevitable. I think every organization in the industry is leveraging cloud for scalability, agility in their business. They want to improve their mobility and collaboration by reaching out to different user base, managing the infrastructure from anywhere. They want to do more experiment and innovation, and cloud is the best place where they can try out new things and throw away once they have done their experiment, which is not possible when you are on data center or infrastructure to have those flexibilities there. And after all of this, the kind of automation that it provides on the cloud is very good, which leads to reducing the operational overhead overall. So in a nutshell, I think cloud is the way to go, and every organization is using the cloud infrastructure or migrating to cloud infrastructure. But that brings to the main challenge or the puzzle when they move from ownership model of data center to the rental model of the cloud service provider. I think that's where the cost starts playing a role. And if we are unable to manage the cloud infrastructure in a way which is cost effective, the rental model is going to be always more costlier, right? But I think that's where the trick lies, how you can manage this infrastructure better, maintain it better so that you can have the lower cost and have the better scalability, agility, and ability to experiment. So that's the idea. So overall, in this session, I'm going to talk about the 3693 strategy that has helped me to work with many clients on solving their puzzle of cloud cost. So the first thing is we need to understand three different types of cloud services that they provide and choosing the right one, balancing the one with the which is more cost effective and operational less, right? Second part is to avoid these six common pitfalls, or I would say common mistakes that we make when we start our cloud journey or begin our cloud journey there. Apply the different techniques or the optimization strategies to manage cloud infrastructure and cloud cost better. So moving there will be very helpful. Applying these 9 techniques will help to reduce the cost. And while doing all of this, we have to make sure that we uphold the 3 pillars of governance. Because if we lose the governance on the cloud infrastructure, it can run into bigger problems with the cost as well as many other security and compliance and all of that as well, not only just cost. So I think holding on to those 3 pillars of governance is equally important there. Moving on quickly with first to understand the 3 types of cloud services. We start with self-hosted, which is the core services of cloud service provider, which is pure vanilla EC2 instances and all of that. Moving on to the managed services, which is where the services are available as a managed service, which is like EKS, MSK, EMR clusters, and all of that. Further moving right towards the serverless architecture, where all of these databases or the compute is available to run the application directly and not even looking into what is the infrastructure underneath like that. Now, when we have to look at these different types of services, we need to understand its trade-offs, which is more important here. So I'll talk about different trade-offs. So when we are into the self-hosted uh, infrastructure in cloud, we get maximum control, which brings better portability. However, it requires very high in-house capability and it may result or require higher effort and longer timelines. However, using the bare minimum self-hosted cloud infrastructure can give you very good cost perspective, right? The lower cost. So that's the side of self-hosted. On the other extreme, we have the serverless cloud services available for hosting the infrastructure, deploying the applications and all of that. It gives you maximum, it reduces flexibility. You have to operate in the way the cloud service provider has given the ability to deploy the applications. However, it requires very low in-house capability. You can just leverage, learn how to do, and rest of the operations are taken care by the cloud service provider. So it brings very lower effort, quick turnaround, and all of that. However, the using the serverless may result into higher service cost. However, if you compare with the operational cost, it might balance out as well. So we need to understand based on the use case what type of application we want to deploy, how it's very high usage, low usage, all of that parameter needs to be evaluated. And based on that, choose your cloud services. Because to do the deploy the application, you can use any of these. You can deploy a microservice application using self-hosted Kubernetes cluster on pure vanilla EC2. You can use EKS also. and you can use AWS Fargate as well. Same way for the databases, you can host your own databases on pure vanilla EC2. You can use the RDS, which is the Postgres or any other databases available as a EC2 machines, but managed by the cloud service provider, or you can go to the totally serverless database like AWS, DynamoDB and all of that. So this is where you have to have the clear guidelines and principle defined for the organizations, which service to use when, and what are the allowed services to be used within the organization. So for that, I think the nitty-gritty lies in defining certain guidelines. So if you have very strong in-house capability for managing the cloud infrastructure, then only go for self-hosted cloud service. If you need very quick turnaround and very short-lived workloads are there, then go for serverless cloud services so that you can use for some time. It's like pay as you go type of model, right? And managed cloud services are best of both the worlds, where you get the flexibility also of the leveraging core infrastructure as well as reduced operation there. I generally recommend to go with mix of 80-20 in choosing the cloud agnostic and cloud specific service provider, which means cloud specific is on the serverless side, where uh, agnostic is more on the managed or the self-hosted side. So that way, if we have to leverage the cloud capability or the cloud service provider specific features in certain cases, we can do that for 20% of the services, and 80% we can keep our services agnostic, so that if we have to port so some other cloud service provider tomorrow and reduce the cost, we can do that. So that's the kind of recommendation that I would give for choosing the cloud services. And make sure that you have a very clear strategy, guidelines defined for choosing which services in which use case. Now let's move to the next part, where everyone is moving to the cloud. All the organizations is in rush to adopt cloud. I would recommend that avoid these 6 common pitfalls or common mistakes that people are making while moving to the cloud. The first one is that when we come from the on-prem infrastructure mindset, over there we ask for what we need 2 year down the line or a 5 year down the line, right? And we provision infrastructure like that in the data center world because we don't know when we get the new infrastructure, right? In the cloud, we have to change that mindset. You have to change the mindset to look for infrastructure that is required only for next 3 months, 6 months, like that. And you can scale it because of the ability to scale dynamically, scale when needed, on demand, gives you that ability to just provision what is needed for next 3 months, 6 months. So avoid over provisioning there. When we move to the cloud, there is always a fear of commitment. And cloud service providers are giving very good savings for commitment based, like savings plans and all. We'll talk about that further as well. So people have fear of doing that. I don't know whether I'll be using it or not, and end up not buying anything. That's the problem. The third is the underestimating the hidden cost of network charges or charges related to observability like CloudWatch and all of that, which we think, okay, it's some cost will be there, approximate this much like that, but then we end up having huge cost. We'll talk about this also further in some of the technique, how to avoid those. Another part is when we have long experiments running. So we start something, then we do some testing or some experiment, and then we keep those workloads running rather than shutting it down. Sometime nowadays, I've seen in the industry that a lot of people are doing experiments related to Gen AI or AI related pilots, and those machines are running all the time. However, make sure that you run your experiment, shut down the machines. That's the key there, and that's the advantage of cloud, right? Another one is not upskilling the workforce. People who are managing the infrastructure in data center are required to start looking at the AWS, whereas they have not upskill in doing the how to manage this AWS better, because the way of operations in data center is quite different than the way you operate in cloud. And that's where we end up continuing old ways of working. We end up provisioning infrastructure in the same way as we used to do in the past. We end up provisioning infrastructure manually. We create Snowflake servers, and that's all the problems that we end up in the cloud as well. So that's on the overall pitfalls that you need to watch out for or avoid while adopting cloud. Now let's move to the techniques or the cost optimization strategies that you can apply while your cost bill is coming high, right? So you can look at all of these techniques and straight away apply in your projects or in your organization. So there are total 9 techniques that I am going to talk about, starting from commitment-based savings, right sizing, managed services, cost observability, ARM processor base, which is Graviton in AWS, networking and data transfer related optimizations, storage optimizations, auto scaling your workloads, and leveraging private pricing and MAP benefits that is provided by the cloud service provider. Let's look at these one by one. The first one is the commitment-based cost savings, which is also known as saving plans and reserve instances in the AWS world. So cloud service providers provide significant discount when you commit to them that I am going to use certain number of compute in a month, in a day, like that. So that way, up to 30 to 70% savings can be achieved. So now for this, I recommend applying 3-step process. The first is to analyze your current usage pattern. Second step is to choose the right commitment type. Whether you want to go with the 1-year saving plan or a 3-year saving plan, whether you want to go with the upfront payment or you want to go with the pay in your bill type of thing. All of this has a lever to percentage of savings that you have, and it is very visible on the cloud service provider page itself. By choosing different types of different types, 1 year, 3 year, the percentage of saving can vary. And don't assume that you have bought once and you will now relax, because your infrastructure is going to vary. Sometime you will have more infrastructure provision for some work. So regularly review and adjust or buy more saving plans. Buy saving plans of 3 year as well as 1 year, so that certain commitment goes out. 3 year will give you long term. So buy certain portion which is 3-year commitment, buy certain portion which you are not sure for 1 year. The tips that I would give is that prefer SP, which is saving plan, for general purpose compute needs, such as ETCIO instances, so that it can be used for variety of purposes. So once you buy saving plan, you can use it for your EKS nodes, you can use this for EMR cluster nodes and all of that. However, saving plans is not applicable for all types of services. So you have to buy reserve instances for managed services like RDS or MSK. So look for that opportunity as well. Because when we look at only compute, it's saving plan, but saving plan does not cover the RDS compute. So you have to buy reserve instance for that. And when you buy this saving plan or reserve instances, buy at the organization billing account, so that if there are some account that is decommissioned later, the still saving plan is adjusted to another billing account, another account of yours in the organization. However, this will bring some complexity of chargeback, budget tracking, because saving plan can go and get applied to one account and doesn't get applied to others. So watch out for that. Have a mechanism built so that you can do the proper chargeback or show back to your accounts that, okay, we are paying some cost at the organization level. You will not see those amounts in the account level charges. So that's on the commitment based savings. Second is the right sizing. Now, right sizing is the most effective one because it can lead up to 30 to 70% of the cost reduction apart from your saving plan, right? Apart from your commitment based savings. Now, for right sizing, you need to have a very good observability. You need to monitor your CPU, memory, storage, all of that very well. Based on the observations that you make, you identify your utilization patterns. And once you identify your utilization pattern, you will realize that you have provisioned 8x large machines for what is required to be only 2x large machine, because you are not consuming that much of CPU or memory there. Also choose the right type of instance. In the cloud service provider, you have different types, R series, C series, like that. Look for which one is applicable in your case. If you need more memory heavy workloads, the R type series where CPU is less and memory more is the right choice or the right instance type for your use case or the workload. This could be possible that choose R type more for the databases because it requires more memory, right? Or if there is a compute heavy workload, choose the compute more compute and less memory type of workload. So instances. So that's very important when you are right sizing, choosing the instance type and sizing it for the based on your utilization. You can size your EKS nodes as well, very well. Having number of nodes, more number of nodes is a better instead of having very large nodes. So choose your number of pods that you would like to deploy. What is the specification of the pod that you have given? And based on that, choose 2x, 4x type of EKS nodes. Also, make sure that your pod configuration is also optimized. I'll give an example that if you are running a Golang microservice, it can run into 100 to 200 millicores as well. Now, we have a tendency where we say that, okay, we have to give one CPU minimum, but 100 millicore to 200 millicore is like 1/10 of the CPU. So you can run 10 microservices in one CPU. So look for what is the right millicore that you want to assign, right? Memory that you want to give to your pods as well. Based on that, the nodes will start or scheduling will happen in the EKS, and you can deploy more pods within a single node. I would suggest that do right sizing of your infrastructure before applying or buying the commitment based saving. Otherwise, you will say today that I am using 100 CPU, so I'll buy 80 CPU on the commitment. But when you do the right sizing, you might come from 100 to 60, and then you are over committed now. And when you are doing right sizing, it is not a one time activity. You have to do this as a continuous practice. So keep doing that, keep working on that. After right sizing, it is very important that you have a peak workload, a peak you will see the peak of your utilization, correct? Now you will right size up to peak utilization. Now next technique comes into the picture where you can do auto scaling when you are in the off hours and when you are in the peak hours. So auto scaling can be done in multiple ways. One is the metrics based, second is the schedule based. So metrics based auto scaling works dynamically where looking at your utilization of the CPU memory or traffic related data, the number of workloads or the pods in Kubernetes world can be increased or reduced. So this is no maintenance. You have to set it up. You can use tools like Carpenter for that. When you don't have a very strong observability stack in place, or you don't know you are not sure that the metrics based will work fine. Let's say for the lower environments like dev environment or UAT environment, where you know that during the off hours, nobody is doing the testing or nobody is working on that. In such cases, you might scale down your number of workloads during the night time. And that's your schedule based auto scaling or schedule based scaling. In the morning time, you again bring up all the required resources. So that's what you do when you are doing the auto scaling. Look for both the approaches, metric based as well as schedule based. Moving on to the another technique, which is the leveraging ARM based processors, which is also known as Graviton processor in AWS world and Xeon in GCP and Ultra in Azure. These are the uh, very cost effective processors as compared to the Intel processor. And most of the applications nowadays are supporting ARM processors as well, including Java, Golang. Even I take example of databases like Postgres, Kafka, all of them supports Graviton. You can achieve more than 20% just by moving from Intel processor machines to Graviton based machines. Specifically, look out for the opportunity where you have a support for Graviton in the managed services. I'm taking more example of AWS here. In the industry, it is widely used. However, similar things exist in the GCP as well as Azure. Look for using EMR clusters with Graviton. Now here you have to consider the compatibility. Your workload needs to be compatible to run on the ARM processor based architecture. So you have to do that compatibility test before you decide to move to the ARM processor. I'll give you one example here. Moving our Elasticsearch cluster of 50 plus nodes from Intel to Graviton gave us more than 50% of the cost savings. It was better performing as well as it reduced the cost of the server. So don't underestimate the savings that you can bring by moving to ARM based processors. Next is the storage optimization. So storage is used heavily, available on demand as much as you need. However, choosing the right storage type is key here. Sometimes we say that the performance of the storage is very important. We go with the very high-end IOPS. So in storage, right sizing IOPS is a key. We have to choose the right cost-effective types, whether it's GP3, IO1, IO2 in case of AWS, and make sure that you don't have anything unused EBS volumes lying around, especially in lower environment where there is a lot of churn of the machines. So regularly check for unattached EBS volumes, do the cleanup, use GP3 volumes for cost effective performance, and it has a bursting capacity as well. Especially avoid over provisioning IOPS for the databases workload or something like that. And many times the Storage is kind of unlimited available in the cloud. People make copies and those copies are lying around. So consolidate, eliminate, duplicate data copies in the cloud. That's the key for storage optimization. Use managed service effectively. Managed service is the key. We talked about it. Leverage as much as possible. However, uh, be careful that it can cost more if you are in the extended support for the managed services. Specifically, EKS is significantly higher cost than the standard support of EKS. So good candidate for managed services are Kubernetes, which is EKS, Kafka, MSK, RDS database, Redis, all of that. Managed services also provides auto scaling capability. Leverage that. Scale your nodes up, down in the schedule based manner or the metric based way using the tools like Carpenter. For managed services, purchase RI because savings plan may not cover it. Check for that and look for the ARM processor support for the managed services. The most important or the unplanned or unestimated cost comes from networking and data transfer. This is what I've seen because whenever we do the cost estimation and planning, we are very good at okay, what kind of EC2 machines I need, what kind of database I need, what are the different managed services I'm going to leverage and all of that. However, setting up the network and the cost of network is feels like negligible, but when data starts flowing across, it is it has been observed that the cost is good amount of number in the actual AWS bill. In this case, look for what is the right networking component that you want to set up for different types of integrations, like one VPC to another VPC communication, from on-prem to cloud communication, from cloud to going to the third-party services, all of that. So there are many components available: transit gateway, NAT gateway, VPC peering. Which one to choose in which case is very key here, especially when we are setting up the multi-AZ and cross-region workloads. Utilize your service mesh and zone-aware routing to reduce this cost and leverage cell-based architecture. Also, optimize your cloud network, designing the cost-effective solution that I talked about, right, for the inter-VPC communication and all of that. Another one is related to Migration Accelerator Program, which is called as MAP also. So CSP provides tool and services to migrate your application from on-prem to cloud. And along with that, they also provide some kind of credit to jumpstart you onto the cloud. So please stay up to date with the new programs that they are coming up with. There are a lot of programs like migration. If you are migrating from mainframe, they'll give you very good MAP credits. Also, when your usage is very high, you can negotiate for private pricing and enterprise level discounts. And this is also a savings on top of all the other commitment based savings that you have. So talk to your AWS representative, work with them, which kind of resources you are going to use more. Like, for example, there are a lot of promotion happening to leverage Graviton more and more. So you can have more savings, extra savings related to Graviton usage. And last, this is very important that all of these above are the technique to save cost. However, one of the key strategy is to democratize your cost observability dashboard to all the team members. Which with this cost observability dashboard, your team can identify cost trends. They can look at spike, investigate why my cost is high. They can themselves gain insights into utilization of their resources and come up with a plan for right sizing or scaling it down. These observability dashboards can generate alerts as well. So make sure that you create these observability dashboards and make it available to everyone. Now we have looked at all the 8 different techniques of the cost optimization. Now look at 3 pillars of the cloud governance. So I talk about real-time insights with automated governance, talk about self-service delivery infrastructure platform to help operate at scale, and shift left your optimization with the application team is able to look at all the data real on the dashboards and leverage self-service infrastructure to manage their infrastructure by themselves. So quickly, real-time insights with automated governance. This can empower the team to look at their cost breakdown, utilization report, operational health, and make their own decisions. For this, you have to have a very strong, robust tagging strategy to be implemented, and also define and create alerts, fitness functions that can continuously monitor and proactively identify risk in your cloud infrastructure. Once you have the good insights and all, the team needs the ability to make changes to their infrastructure. And for that, you need to have a self-service delivery infrastructure platform so that they can do their day-to-day operations themselves. So they can do faster deployment, they can provision their infrastructure by themselves. They can bring in their, and with this automation, you can have a better consistency and reliability in the provisioning as well. And this frees up your cloud operation team to do some other development rather than busy with the routine mundane tasks that they have to do every day. Please increase my number of server from 3 to 6, or please reduce my number from 6 to 3. Provide all that self-service capability to the actual application teams. The last is, once you have dashboards and self-service capability in place, shift the optimization to the application team so that everyone can work together. And instead of managing all the cloud infrastructure centrally, you are empowering the teams to make their own decision with the self-service capability. Now this breaks down the silos also, and the teams can manage their infrastructure better. Moving on to the last part of the session. So we looked at all the 3 types of cloud services. We looked at 6 common mistakes, 9 optimization techniques, and 3 pillars of the governance. What are the key metrics or the KPIs that we should look at while doing this optimization? The first is the spend and budget, spend versus budget, or budget versus spend for every application, for each environment. Cost for services needs to be looked at, where we are spending more and how we can optimize. Look at resource utilization of CPU, memory, disk. Look at ARM processor adoption percentage, and have the healthy stage that, okay, I want to reach, target is 25% in a year, 2%, 3% every month or quarterly increase in that. And have look at how much of the infrastructure is having a healthy observability setup. These are the key KPIs that you can monitor while doing the cloud cost optimization. So at the end, we looked at all these 3693. I would recommend to stay informed about the latest development, pricing model, and the cost structure of the cloud service provider, because these things keep changing. And build your cloud infrastructure using techniques like infrastructure as code, which can help you to evolve your infrastructure in a very smooth and faster way. So that's all about the whole cloud cost optimization, all the different techniques, and what you should watch out for.
Great, Sunit. Thank you so much for taking us through the strategy, and you aptly covered some of the challenges, and we of course saw it in the poll as well. So before we get into answering the audience question, I just want to have a chat with you around 3 or 4 key things that have come out from your presentation. So if we really look at the biggest hurdle, so in your experience, what is the biggest hurdle that large enterprises face in effectively managing their cloud costs? You spoke about some of them in your presentation. So, but if you were really to come down to that one biggest hurdle, what would that be?
I think in the large organizations, I have observed that there are different teams. So we have an application team, we have a cloud operation team, and then there is a DevOps team as well. Now, all of these three teams are operating in silos many times. I'll give you one example where I think how breaking this silo and making them work together has helped eventually optimize cost for the cloud. So when I talked about the example of setting up the Elasticsearch cluster, where we had the Elasticsearch cluster running in more than 50 nodes. We, as an application team, we have decided that we should have a compression algorithm enabled, which is there in the by default enabled there. But that creates a problem for very high communication between different nodes of the Elasticsearch and resulted into higher cost of the network traffic because the Elasticsearch was set up in a multi-AZ mode. So there was a lot of inter-AZ traffic that has increased and due to which the cost was increased. Now, when we had to make, because multi-AZ is required for high availability, however, we can disable the compression or the shrink parameter for Elasticsearch, we can reduce the traffic. So that was one of the key where the application team and the infrastructure team or the cloud operations team need to work together and solve the problem of optimization. So in a nutshell, work application team, DevOps team, and cloud ops team needs to work together when they are setting up the infrastructure is the key.
Yeah. So, in fact, what we see most of the times is that they are operating in silos. And
Yes.
therefore, we don't have, therefore, organizations don't have a single view, a single pane of glass, which gives all the teams, one vision or one truth, which is there. Also, what we are seeing is that as organizations scale their cloud footprint, that is when we largely see the costs going up. So with large enterprises, they're easily spending, let's say, over 100 crore rupees on cloud infrastructure. So what strategies can help them operate at scale more effectively and efficiently?
If I look at the overall number of applications within the organizations, large organizations will have easily more than 200 applications. And these applications will be of different nature, right? Some will be COTS products, some will be like homegrown, custom built products and all of that. So as an organization, we need to have a clear strategy of how we are going to set this application up in the cloud. One of the challenge that I have seen is every application defining their own infrastructure architecture. And that leads to lot of inconsistency and different types of resources or the cloud services being used. So I would suggest have a clear strategy guideline for what type of application will go into what kind of cloud architecture. If possible, have the engineering platform in place, which allows them to operate at scale. So if I say that I have a 3-tier application that I want to deploy, then this is the standard blueprint or the template that I have, which I can use to deploy my 3-tier application. And for that, I have all the automation done in place so that I can do that along with the cloud of team very easily. And these are the ways the optimization can come. So once you have common patterns, if there is a fix that we can do at one place, it can be applied across all the uh, architecture or the applications that we have set up. So automation can be done better and optimization also can be done across the board.
So, Suneet, I would like to take up one more question before we turn into the questions from the audience. Uh, so, so one is that organizations, as they are planning to expand their cloud infrastructure, the cloud workloads, uh, so right from the scratch, they can build on a strategy that is built around FinOps and around better cost efficiency. Now, for an organization that is already struggling with high cloud costs, what are the most effective ways for them to reduce their spending?
It's a difficult one. I think we are already in trouble and then we have to come out of it. So my thinking or the approach that has worked for me is that first stop the bleeding, which means that we have to reduce the cost. And along with that, we have to bring in the right set of governance so that we don't run into the problem again. And to stop the bleeding, I would suggest apply these 9 techniques that we talked about so that you can reduce the bill to a certain level, which is manageable. And after that, have the proper cloud architecture review and cloud governance in place so that any new application which is onboarded on the cloud doesn't go into the same cost problems again and again. Also, when you run this program of stopping the bleeding of the cloud cost, we have to be very careful that we run it like a proper project and manage it, track it, so that we can see actual cost reducing in the bill rather than just at the hypothetical level or at the identification level. So it has to be managed and tracked very well.
Yeah, you are completely right. The proof is in the pudding. So, so with that, I want to come to this question from one of our audience members. He's saying that based on your experience, how much can enterprises realistically save through structured cloud cost optimization initiatives? Is there any number that you can throw around?
Everyone likes number, I think, and it's very difficult to give number for something like this. But I've seen that if I've seen up to 30% of the savings that can happen. Just I've given some numbers also while I was presenting the different techniques where I talked about if you move to Graviton, just from moving to Intel to Graviton processor, you can save 30%, right? Further, if you have proper saving plan coverage, look at your coverage. How much is the coverage? That report is available directly in the AWS console. If your coverage is very low, let's say if your saving plan coverage is only 30-40%, you can go up to 60-70% easily. That can bring in another 30-40%, right? Right sizing will bring another 30-40. If you add all of this, it's very huge. But on an average, if you apply all of this, some of these you are already taken care. So I would not say that everything is applicable in all the organizations. Out of 9 techniques, they are already very good at 3 to 4 places. However, 3 to 4 more places is where they can save. So I would say up to 30% I have seen savings in the actual cloud bill I'm talking about. So we have worked at one of the pharma company. We have worked at one of the bank where we have helped them. In the pharma company, we have helped them reduce we looked at only data workloads, specifically EMR cluster related workloads and optimizing that, shutting them down on the time, reducing, right sizing the actual nodes used in the EMR. All of that has helped them around 25%. And while working at the bank, overall application workload optimization, especially data transfer cost related optimization, all of that multi-AZ optimization, all of that has helped reduce cost of around 20 to 22%.
So you have these examples to showcase the real on-ground cost benefits.
Yes,
That's great.
yes. I do have. I think I talked about Elasticsearch example already. There is one more that EMR workload related, like just shutting down EMR workloads immediately after the whole data pipeline is complete is very key. And because of some or the other reasons, the automation was not working. So we helped them fix the automation of shutting it down, and that has helped to reduce the cost. There are other examples also where we have upgraded the EKS cluster just by upgrading. Nothing. So there were around 100 Kubernetes EKS cluster running in AWS. We helped them upgrade. Out of 100, there were like 40, 50 server clusters were running on the lower versions, which were incurring the extended support cost. So these are
Right.
the very small things, but overall, when you add up, it adds up to large number.
Yeah, absolutely. So before we wrap up, there is one last question from the audience. How does a business and service continuity affect the cloud cost? So generally, cloud providers oversell in the name of business and service continuity. So hence, over usage of clouds. So your take on this?
Yeah, very true and very interesting question that brings to one of the use case that I would like to share is that when we talk about high availability and all of that, we generally end up leveraging multi-AZ heavily. And when we end up using multi-AZ, lot of this cloud service provider gives you amazing ability to set up your infrastructure in multi-AZ with very less operational overhead. However, when you set up multi-AZ, you are ending up in higher cost of two types. One, you are having extra infrastructure. Second, your cost of data transfer increases heavily. So, true, and you have to be watch out for and leverage cell-based architecture. All of that is very helpful for doing this.
Thank you so much, Suneet. There's also a question in terms of whether you can share this presentation with the audience. So we will come back to the audience on that if this presentation can be shared.
I would just add here that all of this that I talked about in the presentation is available in the ebook format. So you can just Google for ThoughtWorks Cloud Economics ebook, and you will be able to get all of this in detail, in more detail than I talked about. So
Right. And yeah. And you also mentioned that you have these case studies where you have seen where you have the actual numbers in terms of how much the costs have been cut down. So I would urge all of you who are listening to us, you can reach back to us or to the ThoughtWorks team directly to understand more of what are the components that go into saving the costs and how you can go about implementing this strategy. So thank you so much, Suneet. I mean, it's really interesting because we come from right from a time where we were looking at cloud as a from a very cost imperative initiative to where organizations were were blindsided by the escalating cost because they went in with the notion that cloud will bring down their costs, and then they started seeing escalating cloud costs and hence the disillusionment. But however, I think now we have reached a stage of maturity where organizations understand that there are different components and hidden costs that go into bringing up the entire cloud cost and how they can optimize these different components to bring the overall cost down. So thank you so much. And I would also urge all of you to please fill up the feedback form. Once you will log out, you will have the feedback form come up in front of you. So do fill in the feedback form, and thank you so much for watching.
thank you, Shipra, and thank you for providing the opportunity to share my experience and learnings with everyone. So I think cloud is, you will enjoy cloud. Don't worry about the cost. If you do well, you can optimize it. Don't worry.
Thank you so much.
Thank you.